Welcome back, everybody. This is the second part of the series of videos of long and synthetic division. Now I'm going to do a couple more examples of long division, but then in the next video I'm going to start talking about synthetic division. Just to briefly go over what the division algorithm is, it basically states that f of x is equal to d of x times q of x plus rx. And over here I listed what each term signifies. And then there's another way of writing this division algorithm, and it says f of x over d of x is equal to q of x plus rx over d of x. Now we're going to be using this definition here in our two examples. But let's go ahead and get started with the examples in front of us. We have 2x cubed minus 9x squared plus 15 divided by 2x minus 5. Now, before solving this problem, you have to make sure that every possible exponent appears in the dividend. If you have a polynomial with a very high degree, for example, let's say to the power of 5, you must make sure that the dividend contains all the powers from 5 all the way down to 1 before applying division. So what you should do here is notice how there's a x term missing. We have 2x cubed to the power of 3, then we have x squared to the power of 2. Before you divide, you have to make sure that there's another term here to the power of 1 before dividing, before solving this problem. And the reason why mathematicians do this is to just simplify the division process. And adding 0x doesn't really affect the division process. And it doesn't matter what the divisor is, as long as every possible single exponent value is visible within the dividend, you won't have a problem with division. But of course, don't forget our last term here, which was positive 15. So I'm just going to extend this just a little bit. And then we're going to do the same thing here, of course. But first of all, let's begin with this problem. So as I said before, you take the first term, and notice nothing changes really. The process is still the same as long as you check that all the powers are visible within the dividend. So we have 2x cubed as our first term in the dividend, and then we have 2x as our first term in the divisor. So we're going to go ahead and divide this by this. We have 2x squared divided by 2x. That's going to give us x squared. Then you're going to go ahead and place it right above negative 9x squared. And then we're going to take this term and multiply it by the divisor. So x squared times 2x is going to give us 2x cubed. Notice how nothing changes. And then x squared times negative 5 is going to give us negative 5x squared. Then we're going to go ahead and subtract. 2x cubed minus 2x, that's just going to give us 0, so we don't have to write that. And then negative 9x squared minus negative 5x squared. So negative 9x squared plus 5x squared, that's just going to give us negative 4x squared. And we're going to go ahead and bring down our next term that we added here. And that's going to be 0x. So negative 4x squared divided by 2x, that's going to give us negative 2x. And then we're going to take negative 2x and multiply it by the divisor. Negative 2x times 2x is going to give us negative 4x squared. And then negative 2x times negative 5 is going to give us positive 10x. Subtracting these, negative 4x squared minus negative 4x squared is going to give us 0, and then 0x minus positive 10x, so 0x minus 10x, that's just going to give us negative 10x. And then we're going to go ahead and carry down our last term, which is positive 15. Negative 10x divided by 2x is going to give us negative 5. Negative 5 times 2x is going to give us negative 10x. And then negative 5 times negative 5 is going to give us positive 25. So negative 10x minus 10x is going to give us 0. 15 minus 25 is going to give us negative 10. And that's our remainder. Now, if you recall, we have f of x over d of x is equal to q of x plus rx over d of x. So let's go ahead and write that. So we're just going to take this part of the equation. We're just going to go ahead and write the quotient plus the remainder over the divisor. So here it would be x squared, oh, there's enough space, x squared minus 2x minus 5, all this plus r of x, which is our remainder, and that's 10, negative 10, over d of x, which is our divisor, and in this case, it's 2x minus 5, and that's our answer. Now moving on to the next problem, I'm just going to leave this here, since we're going to use it again. We have x cubed minus 1 divided by x minus 1. Now notice we're missing a lot of terms here. We're missing x squared and an x. And then we have our negative 1 hanging outside. So what we can do is we can add 0x squared plus 0x. And then let's not forget our last term, which is negative 1 right here. Now, since we have every possible exponent value, x cubed, x squared, x, we can go ahead and carry out the division here. X cubed divided by x is going to give us x squared, and we're going to go ahead and place that right here. X squared times x is going to give us x cubed. X squared times negative 1 is going to give us negative x squared. Subtracting these, x squared minus x squared is 0. 0x squared minus x squared is going to be 0x squared plus x squared. That's just going to give us x squared. And then we're going to go ahead and bring down our next term, which is positive 0x. So x squared divided by x is going to be x. X times x is x squared. X times negative 1 is negative x. Subtracting these is going to give us x squared minus x squared, that's 0. 0 minus x, that's going to be 0x plus x, that's just x. Then our last term, negative 1. X divided by x is going to give us positive 1. And then 1 times x is going to give us x. And 1 times negative 1 is going to give us negative 1. And then if you subtract these, x minus x is 0. Negative 1 minus negative 1 is a negative 1 plus 1, which is 0. And there's no remainder here. So if we go ahead and write our answer in this form, we have the quotient, which is x squared plus x plus 1, plus r over x, rx over d of x. Well, we don't have a remainder here, so we don't have to write that. And we can't have 0 over d of x, so we don't write that at all. So sometimes this tells you that you can't really write answers in this form. So what we can do here is write it in this form, which is f of x is equal to d of x times q of x. D of x, our divisor, which is x minus 1, times our quotient, which is x squared plus x plus 1. And that's our answer. So thanks for watching, everybody. If you have any questions or concerns, please leave a comment in the comment section below. In the next series of videos of long and synthetic division, I'm going to actually cover synthetic division. And I'm going to go ahead and explain what it is and do some examples as usual. Please go ahead and like this video and subscribe. This is going to help grow the channel more, and we'll see you in the next video.